9:05 a.m. on that clock. The meeting's called to order. I'm Felicia Marcus, the chair of the State Water Board. To my left is Vice Chair Fran Spivey Weber. To her left, Board Member Dee Dee Adamo. To my right, Board Member Tam Dodak. And to her right, Board Member Stephen Moore. Mr. Howard, would you like to introduce the staff that's assisting today?
Yes, thank you, Chair Marcus. To my left, Chief Counsel Michael Laufer. To my right, Chief Deputies Karen Turgovich and John Bishop, and assisting the board today are Janine Townsend and Courtney Davis.
Terrific, thank you. Emergency evacuation procedure for those of you who are new to us. Look for the exit nearest you. If you hear an emergency alarm sound, that means it's time to go. Take your stuff, carefully cross the street, and we convene in Cesar Chavez Park a little bit over to the left once you get in towards J Street. And if you go there and stay with the rest of us, you'll know when the all clear comes and it's time to come back if you care to. The meeting is being webcast and recorded, so two things to know. One is that when you get up to the microphone, make sure the green light is on, and you have to talk closer to it than you might think to make it work. Tam Dodak assists me in doing it in my chair because it's hard to remember to do. And please turn your any of your pagers or cell phones, etc., to silent or turn them off, please, just out of courtesy to everyone else. Here we go. We'll go straight into uncontested items since we did minutes and board member reports yesterday. Item number 6, I understand we don't have any cards. Do I have a motion?
So moved for adoption.
Second.
All right, any discussion? All right, it's approved. Thank you.
Aye.
Would you guys like to talk just because you came all the way here? So, okay. I know. Take the vote. All right, item number 7. Mr. Howard, will you please introduce the issue?
Yes, item number 7 is an amendment to the Central Coast Basin Plan to establish TMDLs for toxicity and pesticides in the Santa Maria River and an implementation strategy. Presenting this is Peter Mertens, and he'll introduce the other staff.
Thank you. That's interesting. We have a color theme going here, and we had a color theme going between Janine and Vicky. That's interesting. Just people dressed alike by accident today. Nothing. I'm just showing my observational skills of assessing the audience quickly. Color coordinated.
Good morning, Chair Marcus and members of the board. My name is Christopher Rose. I'm the TMDL Program Manager in Region 3, the Central Coast Region. And to my left is Peter Mertens, the scientist who developed the TMDL before you today. And to his left is Jessica Jar, counsel. To her left is Mr. Danny McClure from the Central Valley region. He is a TMDL program manager in the Central Valley region. And to his left is Amanda Palumbo, who was who took part in the UC Davis criteria development for pyrethroids. And then to her left is Jennifer Epp, who is going to be the new TMDL program manager in Region 3 when I depart from that position. So without further ado, then Peter will, Mr. Mertens will make this presentation on this TMDL.
Right.
All right. Thank you.
You got to pull it closer.
Oh, okay.
Yeah.
There we go. Again, my name's Peter Mertens, and I prepared the TMDL for toxicity and pesticides in the Santa Maria River watershed, which, I prepared a presentation. It's a brief overview of the components of the TMDL, and then I also have some more detailed slides. So I'm going to give a summary of the TMDL development, and then I'll highlight a few areas of where there's more interest. So.
Okay.
So the TMDL addresses 3 classes of pesticide impairments and toxicity in the watershed. The classes of pesticides are organophosphate, pyrethroid pesticides, organochlorine pesticides, and water and sediment toxicity. The TMDL addresses, for the TMDL development, we develop targets, TMDLs, and allocations, and that's a slide that I'm going to go into more detail on. For the TMDL, we did extensive source analysis. So fortunately, we have a lot of data available on pesticide use. We're addressing current use pesticides, which are organophosphate and pyrethroids. And through the source analysis, we also linked the toxicity from water column to organophosphate pesticides, which are currently used, and sediment toxicity to chlorpyrifos use and pyrethroid pesticides. And then through those current use pesticides, we were able to link them through information from like Department of Pesticide Regulations, pesticide use database, to specific crop applications in the watershed and do more detailed analysis of sources. So, during the TMDL development, after the project report was completed, the project report underwent extensive scientific peer review. So this process calls for an unbiased review of the TMDL, and it's implemented by Cal EPA. And for this review, 3 toxicologists and PhDs from outside of California were found to review the document. And they did extensive review, particularly of the pyrethroid, the criteria developed by UC Davis. So, because this was one of the first TMDLs that the criteria had been utilized in, there is a TMDL developed in the Oxnard Drain area that was developed by EPA that uses the UC Davis bifenthrin criteria, but we wanted to have an extensive review of the criteria prior to implementing it. So.
I might interrupt to ask the question. What was the specific question that was directed to the peer reviewers with respect to the UC Davis criteria study?
I don't think I had necessarily a specific question, but, well, the application of it. So we would be taking the criteria, utilizing it for targets and an application in this regulatory setting. So that's kind of one question. The other question is just an extensive review of the methodology for the criteria development. So again, like I'm not an expert in criteria development, and I've learned quite a bit about it during this process of developing the TMDL, and not just from the pyrethroid component, but from, say, the legacy organochlorine pesticide, where more work has been done with criteria development historically. So I was of interest to see how he looked at it, and I was very impressed with his detailed analysis. And it wasn't, and he had questions that we had to bring back to UC Davis for them to review, and then they provided feedback, and then it met his concerns. So.
You said his, so only one of the peer reviewers commented on the UC Davis criteria?
No, all 3 of them reviewed it. One of them had a more extensive background, particularly in pesticide toxicology from Oregon State University. So his review was more in-depth than the other 2 reviewers.
Thank you.
Thank you. Okay, so then the follow-up component after scientific peer review was CEQA analysis. So again, the CEQA analysis, we did one CEQA review, and based on we had extensive comments, particularly from the city of Santa Maria regarding our CEQA process and framework. And based on those comments, we pulled back and completely revamped our CEQA, particularly with assistance from our attorney, and redid our framework, looked more closely at the environmental analysis, and I think developed a much more rigorous process. And then the comments that followed that, we resubmitted that for public comment again, and the comments from the city were, I would say, and much more supportive of that and of the process and the outcome. And even from agriculture too, their comments have been that we were more transparent and aware of the potential impacts based on the analysis. So, and that's kind of leads into outreach. We've done workshops for CEQA, and then also, in addition, I think a key part of this outreach has been individual stakeholder meetings. So we've met extensively with the city of Santa Maria, with the ag groups in the watershed, and then we've we had a lot of comments from the pyrethroid working group, and then last December, we made a trip here to Sacramento to sit down with them, review the comments that they provided and our responses before the regional board hearing so that we could go over those
good.
directly. And we've worked with them in the past also. We've had meetings in the region with the pyrethroid working group where they've come to the Central Coast, and we've taken them out in the field to show them our areas. So, and then we've had public hearings also. So implementation, that's a follow-up slide. I'm going to give you a little more detail on in a moment. Okay. So numeric targets, this is the first of my more detailed slides. The numeric targets, we have quite a lot of targets, I guess, because we're dealing with quite a lot of impairments and different pollutants. So it was a lot of work to put all these together. But I'd say that like the basis and the crux of this, of protecting water quality is probably aquatic toxicity monitoring and meeting those goals where we are free of, which kind of meets the basin plan objectives of not having toxicity and pesticides in our water. So the aquatic toxicity tests are kind of fundamental and very important. And then we developed a numeric methodology for aquatic toxicity analysis, and then also.
Can I ask a quick question? And this is totally up to you, because
Okay.
having looked at the comments and responses,
Yeah.
you're going to, the comments that you're going to get or that we're going to hear later. So
Yeah.
to the extent you want to anticipate and explain, you may already have this in subsequent slides.
Okay.
Feel free to do so. Also, we'll probably come back to you after we hear some of the comments.
Okay.
But so, for example, on aquatic toxicity, there's a lot in some of the comments from the working group about the distinction between water column and sediment toxicity. So if you care to illuminate us on that in terms of your
okay.
thinking, that'd be helpful.
well-
Sometimes the response to comments is a little cramped, so
okay.
I want to
All
give you a
right.
chance
Give
to
me a
elaborate a
opener.
little bit.
Thank you. So, well, I mean, their primary concern is with the sediment toxicity, and so the aquatic toxicity that we've, integrated a TST test, test of significant toxicity statistical analysis, and that, again, is a recommendation. I think it's a suitable. I reviewed the, again, I'm not an expert in statistical analysis of aquatic toxicity testing, and there are other methods that can be used, and we currently have a different method for our ag program. So we're making a recommendation, and a lot of the concerns that have to do with toxicity testing and statistical analysis have to do with kind of maybe lab results. But again, the quality of the programs that we have and the monitoring that we have in our region, I think the TST is a suitable methodology.
Right.
for it.
I know that that's an issue because we're dealing with it
Okay.
in all our toxicity hearings. I meant the distinction between what's toxic, the water column or the sediment, and what the difference it makes.
Oh, okay. Well,
I mean, to a layperson.
to a layperson, oh, okay.
I have a fair amount of experience in this, but I'm a layperson,
Oh, all
to be
right.
sure.
Thank you.
You're probably doing all of this because of something crazy I did a decade ago, so.
Oh, okay. Well, I appreciate your craziness back then.
I don't know.
The aquatic toxicity, we're dealing with water column toxicity to invertebrates and the test organism is to Ceratophrenia, and we were looking at standard testing for chronic and acute toxicity. And then we're doing sediment testing to Hylella, which is generally a test organism that's sensitive to pyrethroids, or a good indicator of it. I shouldn't say necessarily sensitive to it, but an indicator of Hylella.
Is that sediment?
And that's in sediment, yes. So, okay.
All right. Well, I'm sure we'll come back to this. Go on. I'm
Okay,
sorry to
I'll be
break your
ready when you
train.
come.
It will be here.
Along these lines, though, when you look at the comments, the crux is the big words at the top of your slide here is numeric targets.
Uh-huh.
And I think it would be helpful to explain from staff's standpoint, and John Bishop may want to chime in as well, on how numeric targets are used in a TMDL. Because the issue is the use of this science peer-reviewed endpoints and thresholds in the TMDL,
That's a great question.
and the concern that they're somehow elevated to the status of a standard, but really it's a numeric target.
Oh,
And
yeah.
so, these numbers that you select, what is their role in the regulatory process?
Well, and if I could just jump in and add to that, because there's an irrigated lands program that, as I understand it, the region has indicated that the existing program would be good enough, for now. But the irrigated lands, the order actually refers to TMDLs and requires compliance with TMDL. So if you could comment on that as well, it'd be helpful.
Oh, sure.
Yeah, paint us a picture of how this unfolds.
Okay,
in the
well, let
real
me
world.
take a step back from just looking at the
Yeah.
particular slide. And I think one thing is that, yes, we're developing numeric targets. So we've got basin plan objectives, which is a narrative for toxicity, and that's really the standard that's been approved by EPA is what's in the basin plan. Then for the TMDL, we're developing targets that are interpretations of that numeric narrative. So how do we know we're meeting that narrative for this particular pesticide or a toxicity issue? So we're showing that at this level of toxicity or at this sample level of a pesticide that the water is safe and protective and meets that beneficial use. That's a narrative. So that these are numeric ways of interpreting that narrative. And then what we've also done is separated out allocations in the TMDL, which is a big distinction
Right.
between standards or objectives written into the basin plan, where these numbers and numeric targets are targets in the basin plan when they adopt the TMDL, but they're not objectives written into the basin plan.
Right. This is a target for what time frame? I thought I read 30 years somewhere in the material.
Yeah, this is a target to achieve the, to achieve these targets, we have time frames and milestones within the TMDL
Okay.
to meet those, yes.
Can I clarify for just a moment? Thank you.
I know some of this is so basic to you and what you do all the time, but remember that these hearings are not just for the people in the room. They're for people who may be listening and for the public policy goal of illuminating the decisions and the basis on which we make our decisions. So
Sure, thank you. Again, I'm Christopher Rose, the TMDL Program Manager in Region 3, the current TMDL Program Manager. To elaborate on what Peter said about numeric targets versus allocations, numeric targets are predictions of when we will achieve water quality objectives. So in this particular case, we have numeric targets that are expressed in terms of water column concentration and in terms of sediment concentration. And again, what we are doing is we are predicting the concentrations necessary in order to achieve our water quality objective, and in this case, for toxicity, our general toxicity objective. The real water quality objective in this case is our general toxicity objective. And the numeric targets, as some of you know, they are not enforceable targets. They are not a water quality objective. Again, they are simply a prediction of the concentration that we think will be necessary in order to achieve the water quality objective. But it's the water quality objective toxicity that makes its way into permits and so on.
So can I try a slightly different approach and see if that helps, because I'm seeing a little bit of. So the way that in general TMDLs are set up is that you you develop a target to say, we think if we achieve this in the water body, then we will be protective beneficial use. And then we develop waste load allocations that are designed to achieve that target. And the waste load allocations are what are translated into permits as permit conditions. And then you check on, did all these things work in your development? You make a lot of assumptions in doing TMDLs. You have to and when you develop those waste load allocations, so you put the waste load allocations in permits, you work to meeting those, and you check on all that assumption by looking at the target within the receiving water. So it's an independent look to see if the TMDL itself is was accurate or correct when you put it together. There are two ways that it can go, and we've seen both of them in our TMDL program. You can be meeting the target before all the waste load allocations have been implemented, which means that your TMDL was more conservative than necessary, and you ought to be considering at that point that you've met your target, you've met your conditions, and your TMDL is a success. The other side of it is that you can meet all your waste load allocations, and you're still not meeting your target within the receiving water. At that point, you need to assess, did the assumptions that you went into the waste load, you may need to redo the TMDL to address this lingering problem. So they are not enforceable numeric effluent limits. What they are is a check on all of the assumptions that went into the TMDL.
And in some way, and I appreciate that, and in some ways, then, as you described it, the target is a way for us to evaluate our performance in terms of the TMDL outcome. You know, have we attained the TMDL or not? It's like you say, there are assumptions built in, so it's not hard and fast regulatory, but it gives us all a guidepost as far as if we've achieved the outcome environmentally.
Right, it's a tool.
It's a tool.
Okay, thanks. Sorry, just
No, thank you. I appreciate that. Okay, so and then that's what we've developed for this project, are these guideposts to gauge when we're achieving and protecting the surface waters. And again, we've developed them for organophosphate pesticides, looking at the water concentrations. Are those concentrations safe? And those are based on, again, numbers that we've used previously in TMDLs. Then we've also got additive toxicity formulas, because we could have multiple impacts from pesticide within the same class of pesticides. And then for organochlorine pesticides, we're looking at fish tissue and water and sediment concentrations. So, okay, so again, that kind of leads to a more detailed look at the pyrethroid criteria development. And I wanted to add that we have, fortunately, we have 2 people at the state board level that have worked as graduate students, and one of them is with us today, Amanda Palumbo, and Tessa Foju isn't with us today, but she worked extensively also on their development. So if we have more detailed questions, Amanda's available. And then also Danny from Region 5, McClure, he worked on the development of them, so he can answer questions in more detail than I am able to. But I'll try to give a brief overview on that. And I think going into this TMDL, I researched and reviewed different criteria that would be appropriate for the targets. And then in that process of looking at pyrethroid pesticides, when we identified them as causing problems, I started to look at the targets available for that. And through that process, then I came across and talked to Region 5 and found what the work that they've done. And again, I think maybe a key component is, well, I'm not going to go into the specific methodology and break it down for you, but that the process of developing the methodology is the science, is part of the whole scientific process that gives me so much confidence in utilizing their numbers, because they extensively reviewed a lot of different methodology in the first phase of it throughout the world, looking at different programs that are developing criteria to protect water quality from pesticides. And then they looked at that and then looked at our needs here, and then determined that they need to develop their own methodology, and they adapted the existing methodologies and then developed one that meets our regional requirements. And then based on that, they went back and got extensive scientific peer review and public comments on that. And then they took the methodology and applied it on individual pesticides at a case-by-case basis. Then each one of those brought forward for scientific review and public comment. And, Danny shared these with me today. He goes, well, they've been published in scientific journals. So it's not just, they're extensively documented on their webpage, which is very transparent and available to the public. And all of the, and many groups are available. Yes, go ahead.
Well, and my question is, particularly since Danny's here, thank you for being here, and glad you're here too, so you can kind of chime in. Region 5, as I understand it, is doing a more extensive, I assume they have more pyrethroid use in their region, but you're doing quite an extensive investigation as you are developing your basin plan amendments to reflect the new study. So could you describe why you're doing such an extensive study and you know, kind of what you expect to find from it that you wouldn't have, that you know, why didn't you do what Region 3 is doing in a way?
I'll attempt to answer that and let me know
Okay.
if I'm kind of on the right track. But this, to give you a real brief backstory, when we were working on diazinon and chlorpyrifos, that's the criteria that were used there. They're often used there are based on some fish and game criteria that were derived using a 1985 US EPA methodology that's kind of the standard methodology for aquatic life protection criteria. So we had a lot of comments on that, you know, hasn't there been new science since then, but that is kind of still the standard method used for aquatic life criteria duration. So because of that, we've, you know, funded then, hired UC Davis to do those studies that Peter described, kind of some of the process. And and a couple of the main kind of things that we wanted to see in improving some of the way the US EPA criteria work out are, one, we wanted to include a standardized process for doing QC on the toxicity test that went into it. So because there was actually some issue with what tests are valid to use in deriving the criteria. That became an issue that we actually had to revisit one of our TMDLs because of. And so that was one thing. And the other thing was the availability of creating a method that was a little more robust so that it could be used with existing data when there's not as much toxicity data available. What happens is when pesticides are registered, there's the only guaranteed data for 3 taxa, and you need 8 to use the US EPA criteria. So we've been in a situation where we don't have a lot of criteria. Yes, it is a little shocking, but so we wanted to have a way to have a more robust method. So those were kind of some of the things, and then just, you know, update it and relook at everything. So that was the reason behind it. Does that answer the question?
I have some questions on that. I'm still a little confused. When you say more robust method, does this go to the water column issue and the tests that might provide for concentration of organic matter as opposed to the test that's being used that doesn't have as much organic matter? This is on pyrethroids.
Yeah.
So, I mean, that was definitely something that the researchers looked at. And, you know, they suggested a way to, you know, when possible, where you could adjust for the bioavailable fraction.
So yeah, I would agree. The methodology considers bioavailability, but there at this point there's still some limitations on how well you can do that to, you know, consider the amount of pesticide that's freely available to cause toxicity to the organism. But so we did as best as we could. You know, the EPA method from 1985 didn't have anything, but there's still not a real super way to do that, a super great way.
And so what's the process to, are you with Region 5?
No, she's with
No.
us.
I'm currently with the
Davis.
state board, but I was involved in the development of the methodology by which the criteria are calculated, and I was involved in the bifenthrin criteria calculation several years ago when I was at UC Davis.
Okay.
So somebody had another question?
Well, I was trying to, the phrase that you use, which makes sense to me, is you do the best you can. So this is something that will be continually reevaluated as the science gets better and better, right?
Yeah.
And so I would just assume that in setting these targets, you would set them somewhat conservatively, right? Because you don't want to guess the wrong way, given that this is one of the key elements of toxicity in the aquatic environment, right? right?
Right. So I think what ends up happening is the target can be used conservatively or more accurately, but the way you end up measuring in the field, or the field data that you have, end up being more accurate or more conservative depending on the tools that you have. And we knew at the time, you know, when typical field monitoring isn't, it's not going to be able to measure maybe the most accurate bioavailable fraction of the pesticide, but it is the best we can at the moment.
So let me give you a background on how criteria is set. Normally,
This is like we have this ringer here.
that's okay.
Mr.
Just-
TMDL.
I'm not good at the detailed technical, but putting it into a different wording is.
Right,
The,
right.
our criteria for all of our toxic chemicals are done by using lab methods to evaluate it. It is understood that the water used in the lab method is much purer than the water in the environment. And so that gives you a more conservative number than you would
Oh,
have.
actually, the other way than I was thinking.
So, well, it's more conservative in such that if your value is 1 for toxicity, in the environment, it's likely to be higher than 1 because there are other things that interfere that make it not available.
Oh, okay.
And so there are all of our toxicity-related compounds, our metals, our organics,
Right.
have this issue related to them.
Right.
Standards are set using lab water that's very clean.
Yeah.
That means that we know they are conservative values, and that for some of them, there are good ways to do site-specific objectives to evaluate that. With metals, you can do a water effects ratio type work, which then takes the more conservative and looks at what is its real toxicity in the environment is. And so we do those kind of things, but you can only do them on a site-specific objective. You can't do that on a large scale because that bioavailability changes
Right,
with the
varies.
waters.
Right.
So that's the kind of the general background on how those work.
Well, but on site-specific, could you put that into context? I'm thinking of agriculture. So site-specific, we'd have to go to certain regions to
So-
determine if there's a water effects ratio with respect to the issue I was trying to get at, the organic matter, where the pyrethroid may bond to
Right.
the organic matter.
So it's the same idea. I don't believe they call it a water effects ratio for pesticides, but
Maybe I could help.
Sure.
I think one thing that's helped me with this type of visualization of the problem or with pyrethroid pesticides, is they partition in the environment. So when you have, and that's kind of what we reflected in the TMDLs and allocations, and I'll explain that a little bit further. But the pyrethroid's likely to move off farms or out of the urban environment bound to sediment or organic matter in the sediment. So it binds to organic carbon. Then in the aquatic environment, if you place that sediment there, it's going to partition. It's going to reach an equilibrium between the amount that's bound to the sediment and the organic carbon, and then that's dissolved within the water fraction. What the numbers UC Davis have developed is that little bit that gets dissolved out there is likely going to kill, is at a level that won't kill an organism. So what happens is that pesticide partitions into the free fraction, and then an organism can uptake it and be killed. So we need to find a concentration where that doesn't happen. And that's what UC Davis and criteria and the targets do. They say, this is a number when we're not going to have a problem. It's not a number that maybe we want to use for other tools, but it's the number that
It's the
we're going to say the aquatic
target.
health is good and we meet the objective.
Right.
And then another thing I think that might help is that when I was developing this, I thought, well, let's not rely on one tool. We've got a few tools because agriculture monitors toxicity regularly in our region. They do 4 times a year. They're doing sediment, water column toxicity sampling. And they're familiar with that process. They've worked closely with our ag monitoring, cooperative monitoring program. So let's use the tools that we have, and actually the urban folks said the same thing, so let's look at toxicity. So we're backing each other up. And then also I added sediment targets based on LC50s, which aren't all that protective, but are a good indicator of like what's the sediment quality in these receiving waters. And you can add those up because you're looking at LC50s and the toxicity of that sediment. And those are based on scientific studies as well, but they're only LC50s. So,
LC50, why don't you define LC50?
oh, it's a lethal concentration that would kill 50% of a population. So that's not good enough. We
Right.
want, we need to have usually like 90% or 80% to say it's a healthy system with a pollutant in it. So
You did a nice job of describing, some of the conservative target setting. Would you say, and forgive me for not remembering, but is part of the margin of safety within saying you've attained the TMDL, the use of a numeric target that might be a little on the conservative side, presuming everything in the water column
yeah.
is available? Did you tie that into your margin of safety?
Yes, I did, yeah. So, all right. So that, are
Interesting.
there other questions?
Thank you.
Okay. So I'm going to move on from this. I think we've covered it pretty well. But, and then this kind of leads to the TMDLs and allocations. And generally in TMDLs that are concentration-based, have concentration-based targets, often the allocations or the TMDLs mirror the targets. In this situation, they generally do, but again, in the pyrethroid area, we took a look at it and we had feedback from our stakeholders, and again, looking at the fate and transport, these pesticides are going to move out of urban areas, generally bound to sediment, off of farm and sediment, and they're which is a controllable fraction. So the allocations generally match the targets, except for with pyrethroids, we linked it to toxicity, which they're already monitoring for in agriculture, and then additive toxicity formulas, so we can look at the specific material, so we can troubleshoot where the problems are coming from, and look at the dischargers can look at like what pesticides are in our water, so
Right.
and then control them to get them down to levels that we're meeting the objectives. So and then
let me
Nope.
follow up a little bit. Going back to you from Region 5, they are looking more extensively at the test because they don't, because they want to make sure they want to make sure they have enough, or they don't have enough toxicity samples. So this test is supposed to sort of substitute or be a tool for
Yeah.
getting around that problem. But you feel confident that you don't need to do that kind of work, or you can rely on their work,
yeah.
so that it seems wasteful to have two people doing the same work. So
Yeah.
that's good. So could you talk a little bit about how you see using what is learned in Region 5 for what you've got?
Oh, yes, sure. I think that the Region 5 work is very, very valuable. It's it takes a lot of resources that we wouldn't have in the Central Coast region, and I think it's good communication that we link together. I work on a pesticide group with Danny, so we have regular communication between the different regions, and then I think that as we develop these numbers, I think you can apply them in TMDLs and utilize them. One reason why we use aquatic toxicity in the TMDL is because we're following a model that actually Region 2 developed for a pesticide TMDL in the San Francisco region that generally we look at as a very successful TMDL that has made big strides in improving urban pesticide runoff. And they were addressing pesticide problems like diazinon at the time, but they incorporated toxicity as a numeric target, which then that allowed them to link future pesticide problems and criteria into the TMDL, and they didn't have to rewrite the TMDL. So it created more efficiency, and it also, I think, relieved burden on dischargers, where the dischargers could work within an existing framework. So Really, if I was to take everything out of this TMDL and only have one target or one allocation, it would be toxicity, and then we could do what Region 2 did and link it to other problems. Because the listing policy allows you to link toxicity to pollutants, and that's why we were able to bring pyrethroids into this partially too, because the listing policy says, well, if you can attribute a toxicity to a pollutant, then you need to link it back and bring that pollutant into the listing. So in Region 2, they've added additional pollutants and addressed them based on studies. And
If I could add to that, Ms. Weber, just a little bit. Again, my name is Chris Rose. So your question was, how would we incorporate what Region 5 finds into this TMDL? Well, like all of our TMDLs, if we found that the water quality objectives or numeric targets change in the future for not only this TMDL but other TMDLs, then where appropriate, of course, then we would revise our targets and our allocations, not only in this TMDL but other TMDLs as well. That we would do that. We would do that. Also, I just want to elaborate or maybe summarize what Peter said. And just clarify that the pyrethroid criteria that we're looking at, Peter has used them as numeric targets, not as the allocations. So I'm not quite sure where Region 5 is going to end up if they're going to use those numbers, those criteria as allocations, but we are not using them as allocations in our TMDL. And remember, it's the allocations that end up in the actual regulation, the permits, and so forth. We're just using them as numeric targets, as I said earlier, that are predictions of when we will achieve our water quality objective, the water quality objective being toxicity.
That was an excellent clarification, because, I mean, in some TMDLs, as Mr. Bishop pointed out, it does translate into allocations and ultimately permit requirements. This is an important distinction, that in this proposal, you're using it as an evaluation tool for the TMDL attainment for toxicity, but not as a tool to then have numeric permit requirements.
Exactly. And
That's
I
an important
also would
distinction.
just like to remind the board, if you haven't seen this in response to comments, that in the earlier drafts of the TMDL, the numeric targets for pyrethroids were originally allocations. And the responsible parties, the stakeholders, asked that we take those out of the allocations, put those in the numeric targets, and instead for the allocations, use general toxicity. And that's what we did.
okay.
I know it's taken a while, but it'll make
Yeah.
this a conversation with everyone that will go ultimately faster and more effectively. So
Yeah.
thank you for
I
your.
think it's working. Okay. So again, with the allocations, I think there's some important distinctions here too. So I'm not going to move away from the slide quite yet, but we have the TMDLs, and then how they're allocated to the different responsible parties or sources is kind of unique also, or I think it's important to clarify a little too. Aquatic toxicity is linked to both urban and agricultural currently used pesticides. Then organophosphate pesticides in this region, they've been banned from a lot of them, chlorpyrifos and diazinon, from urban use. So, and our main source is irrigated agriculture. Then additive toxicity for organophosphate, that would be applied only to agriculture also. For pyrethroid pesticides, we have agriculture and urban sources. However, we've noted, I think, that I'd like to note that we have the level in the urban drainages was much more elevated than we had in the agricultural zones.
Right.
And then
Is that
organochlorine.
just because pyrethroids are used in termite control or a particular urban pesticide application? I've been meaning to ask that for a while. Do you know?
I think it's because they're pretty much the primary urban pesticide for all.
Like everything?
Yeah, I think we've got some experts behind us that can elaborate, but
Raid?
generally if you go
Are
to
we
the-
talking raid here?
Yeah, exactly. So anybody in this room, if you walked into well, I won't mention any stores, but if you walk into any hardware store,
Right.
if you walk into any hardware store and you pick up some insecticide, if you go in there blindfolded and go to that aisle and pick it up, chances are you're picking up pyrethroids.
Right. I'm remembering this from some of the Delta Council meetings we
And
had.
that is why this is an urban stormwater problem, and that's why we got so many comments from the urban stormwater stakeholders.
And so this would be, just jumping ahead to the and again, this is not setting the numbers in permits as we look at this. Ultimately it's all connected. So when we talk about our stormwater strategy for off into the future and source control,
You got
this is your major source of toxicity in the urban environment.
Yeah,
So
That's right. That's
so
right. That's right.
Yeah, and I'll talk about implementation in the next slide, but I think that's partially why we've gained support from the stormwater associations is the framework we've outlined in this
Right.
PMDL in
Noticed
terms of implementation. And, but I'll go into that in the next slide. Before I do, I want to talk briefly about organochlorine pesticides. So we did have kind of a, we've had some big problems with organochlorine pesticides and some detections in along the coastal watershed in sand crabs, and we've done multiple studies, and then also Swamp did a study in the region, and we had high levels in fish tissue. So that's why we're a little more aggressively, or including them and addressing them in the TMDL. And one of the components is that we found them in flood control channels and drainages and roadside ditches. So initially, when we were developing this TMDL, we had input that said, oh, maybe it's, sources like deposited, dump sites or something that we're getting leaks from. But with the monitoring that we did throughout the watershed, we found kind of like ubiquitous, a little bit everywhere. And so we looked at these flood control channels as something that needs to be, have management plans maybe possibly too and stabilized. So I'll move on. So implementation relies extensively on existing water board programs. The existing ag order, again, should meet the requirements for implementation, monitoring. The monitoring program is very rigorous and aligns itself with the requirements of the TMDL. And then also long-term monitoring and reporting. They do annual monitoring reporting that should show us indications of watershed change and progress. The stormwater permits will be the program and that the MS4s use to implement waste load allocation of plans, attainment plans. The TMDL also recognizes the management agency agreement that DPR and the water boards have as a implementation plan and program. There's a California pesticide management plan that's between the water boards and DPR. And part of that framework has led to, or this association that we have with DPR, sharing of monitoring data and information, and also DPR regulations like urban pesticide regulations that they enacted in 2012 that should go a long way towards improving urban pesticide problems. So I think the research has shown that a lot of the sources of pyrethroids are professional applications and pyrethroids, and these DPR regulations are aimed at changing the way professional applicators, those folks that you call on a monthly basis to come out and spray, how they apply. And to give the pyrethroid working group credit, they did a lot of research on different methodologies and how that movement of pyrethroids moves from different surfaces and how they can be best applied in source control versus the stormwater programs trying to catch the stuff at the back end. So I think this is an important development. In addition, we've had a lot of concerns from agriculture about chlorpyrifos use. So I'd say the most important regional issue is the use of chlorpyrifos for, say, broccoli growers in the Central Coast region. And we're coordinating with DPR and the local ag commissioners on ways to develop regulatory tools that could allow the county to help work with them on permits that would allow them some flexibility with the ag order and the Tier 3 monitoring requirements. So, and I should have mentioned under the ag order that Tier 3 monitoring is an important component of checking for movement of organophosphates off of farms. So, and then EPA regulations are important. Also, label changes have taken place in recent years with diazinon in particular. It was an important pesticide for use on our crops on the Central Coast, and EPA has greatly restricted the use of diazinon on crops on the Central Coast. And in addition, I've outlined in the TMDL technical report pyrethroid label restrictions for sediment control that are requirements when you use pyrethroids near aquatic habitat. So those also go a long way towards achieving our implementation and don't fall within our, our water board programs. But okay, let me go to the next slide. Okay, so here comes the fun one. We had a lot of public comments at the regional hearing and also for the state board hearing. I'll kind of give a brief overview of each of the groups that commented and their comments. We had comments from the California Association of Sanitation Agencies, and there's an issue with pyrethroids moving through sanitary sewer systems, wastewater treatment plants, and the ability for those treatment plants to remove those pesticides. I think it's a serious concern to meet the targets if they had to meet those at an effluent limit through through their discharge. In our watershed, we don't have any that discharge to surface waters. They discharge to land. It's less of a concern in this watershed. So that was kind of our response in their comments.
Can I make just a quick gratuitous, well, it's not gratuitous, it's serious, just unsolicited piece of advice for, I don't know who wrote the response to comments, but I just want you to know I have sort of strong feelings about responses to comments and have for a few decades since I was doing documents at the local level. When you're doing response to comments, whoever's doing them